I gave you this list last time. The list said that when you're solving an antiderivative problem, if you can use a formula, you just use it. We're going to do more talk on U substitution today. But sometimes you just have to do a little bit of algebra first before you can use the formula. So that's the situation here. We have to rewrite this like so. Use the constant property to pull out the negative 12. Questions are there? Now you can just use the rule.
I don't understand how you did that first step. Getting from the fraction to just the negative 12.
From here to here?
Yeah.
So there's a property you have to have memorized. The property is that 1 over pretty much anything x to an exponent. It's the same thing as x to that negative exponent, or vice versa. So you could say 1 over x to a negative exponent is x to the positive exponent. So I'm just using this one here. Okay. Because the 12 is just a multiplier, it just stays where it is really. So I don't know, maybe this would help. Try this maybe, I don't know. Put in one extra line here, like so. Pull out the 12 first, maybe. Might make more sense. So you have negative 12. Then you would have 1 over x to the 4th. Then you'd have negative 12 x to the negative 4. So either one of those.
Yeah.
Good question. Take it for Soren. Other questions on that? Please.
For the answer, are you allowed to leave it to a negative exponent, or will they want it 4 over x to the 3?
They don't really care. On the written portion, this is just fine. On the multiple choice, I've seen it both ways. So they may write it like this, but they may write it like this as well. There's actually no rule. Some teachers will say things like, oh, you can't have any negative exponents. They're just expressing a preference. There isn't no rules. Oh, take it for Aspen. There you go. Please,
What was 30?
read 32 there.
Antiderivative 4t plus 7. And like I get like what you're supposed to do and stuff, but it's just the I'll try it out.
You're good.
4t plus 7. So I get you pull it out, the 4, then you do t squared over 2, and then 4. The 7, I just know like if you go backwards, you just would put a t there. Is that a lot? Is that how you do the think about, or is there a different
That's
way?
perfect. That's perfect.
So,
No, you're doing great. Let me make a comment for the whole room, though. Look up. Everybody look up on this week. Just look up. One of the rules that will work with this is the ax plus b to a number rule, because it's ax plus b to the first. However, please make a note on your rule sheet. Let's come back here. Okay, the rule works if this is equal to 1. There's nothing illegal about it. And if you did it on the written portion of the test, you get full credit. But on the multiple choice portion of the test, they're not going to use this rule when the exponent is 1. So I'd make a little note. For this particular rule, don't use it if the exponent is 1. You can't use it if the exponent is -1, because you get a 0 in the denominator. But they don't usually use this if the exponent is 1. It's just, there's a simpler way, so they just won't do it.
And that's only just for that one.
Just for this rule. This rule here, Ellie, you can't use this one if x is equal to -1. But if x is equal to 1, it works just fine.
And it's just for that one also.
Just for that one. Pretty good there? Cool. So back here, the first thing I would do, Derek, I think you got it all, I'll just write it out. I would break it into 2 antiderivatives, basically. And you are correct. There's another way to solve it, but no need to know it, because the easiest way is, yeah, 7t.
Okay, so it's not.
Pull out the 4, this becomes t squared over 2.
Okay. Okay, just making sure I was like not doing it for doing it. For
Totally understand. Yeah, you always want to be on guard on thinking something is legal, and then maybe you didn't really notice that it wasn't.
Yeah.
But in this case, totally legal. The derivative of 7t is definitely 7. Therefore, the antiderivative of 7 is definitely 7t.
Okay.
Perfect. Please.
Can you just go over why, like, 7t? How do you get the t?
So what Derek's doing is he's just thinking to himself, okay, what does antiderivative mean? Antiderivative means that I had something,
Oh, okay.
found the derivative, so what's the sum of 7t? Please.
If you think about it like it's t to the 0, so there's no t, like, does that work? So
Huh?
just add 1.
Yeah, here's how Sydney's thinking of it. If you got the antiderivative of 7 dt, that's the same thing as the antiderivative of 7x to the 0 power. Sorry, I guess t, back up, hold on. So it'd be 7t to the 0 power. Because anything to the 0 power is 1. And 7 times 1 would still be 7. So now you can actually use the rule. 7 is just a constant. T to the 0 plus 1 divided by 0 plus 1. That's it. So the rule does work. Either way. No? Let's bring a different question with you to class. Cool. Okay, today we're going to focus on the rest of the period on U substitution. The homework is the remaining problems on the buck sheet. Okay, the most important thing, as always, is, okay, everyone look at me, please. Look up, come on. Look up, look up. Look up. Today really is one of the most important days to be, like every day is important in calculus, as I think we actually mentioned last time. Most people are not really anxious to miss this class. In fact, I have a lot of people who will come to different periods just so they don't miss the class. Today's kind of just a step above that. It's like it's just a really important day to make sure that every little thing makes sense. U substitution is not difficult if you do a few examples and make sense of each idea. Once you get the pattern down, it becomes a very easy procedure. But just keep asking. So write this down on your paper, please. Write that one down. Okay, with U substitution, I was talking about a little process that we go through to see how to get started. That process is you first think to yourself, I want to know if U substitution is going to work. Because U substitution doesn't always work. You think first of all, okay, are there two functions being multiplied? Someone answer that. Can you see this antiderivative as two functions being multiplied? And if so, can you tell me what to write down as those two functions, Len?
This is kind of just a stab in the dark, but is the first one y over y squared plus 5, and then the second one would be dy?
Really good answer, ticket. Not in this case. The reason is that when we're doing an antiderivative, this symbol and this symbol really are simply telling us what to do to the stuff in the middle. So they're saying to find the antiderivative of this. So when we're trying to find two functions that are being multiplied, we're just focused on what I circled. Comment, Chance.
So two functions, one would be y, and the other one would be 1 over y squared plus 5.
Perfect. Take it for that. You have a question about how we did that? Awesome. The next thing you think to yourself is, okay, there's 5 different forms that I need to be thinking of. Something to a number, e to the something, 1 over the something, sine of something, and cosine of something. So I'm thinking of those 5 different forms, and I need to identify which of those forms the two functions fit into. So somebody help me. Which form does this one fit into? Which form does this one fit into? Bailey, please.
The first one is something to the n, so y is equal to the n, and then the 1 over y squared plus 5 would be 1 over something.
Nicely done. So if we look at this one, that leads us to the next thought, that the u we choose, it's always the something. Remembering that this little parenthesis thing, you're not going to see this in a book or online. This is just my little way of representing something. Okay? We don't always see parentheses. For example, Bailey, up here, you said it fit into this pattern. So what's the something and what's the n?
Well, y would be the something and 1 over the n.
Yes, you done. The u is always, our choice of u is always the something. So one possible choice for u is y, because this is y to the first. The other choice of u is the other something. Somebody else tell me, what's the other something? What's
Y squared plus 5.
y squared plus 5? Is there a question there? Please.
Why isn't it 1 over y squared plus 5?
Simply because the pattern that we have to follow for U substitution is we identify the two functions being multiplied, and then each function's got to fit in one of these forms. So the form is 1 over something, so the something is our choice of U. Okay? This might help, Mikkel. If you remember back when we were doing derivatives, if I were taking the derivative of, say I was doing the derivative over dt of the natural log of, this problem is, what is it, y squared plus 5? Yeah. If I were taking the derivative of y squared plus 5, what I'll often say when I take the derivative is I'll say the derivative of, this should be a y, sorry, hold on. I'll say the derivative of the natural log of something, and the derivative log of the natural log of something is going to equal 1 over that something, y squared plus 5, multiplied by the derivative of that something, which would be 2y. We're really kind of following that same pattern. So we're not really thinking of the whole thing, just 1 over the something. Does that help a little?
Yes.
Okay. Here we go. Perfect. Here you have 2 choices for you. A couple things you got to watch out for. First thing is you never want to make your choice of u this, because you won't be accomplishing anything. Yeah, all you'll do is change every symbol from y to u. It's the same as when people ask me, hey, I don't like using t, can I just put an x in place of t? You haven't changed anything, you're just using a different letter. Are we okay on that? So you don't want to ever choose this one. If u is just equal to y, no, we're not going to choose that. So this is really our only choice. So go back over here. And you don't draw a line divide the two halves of the process here. And we simply say let u equal y squared plus 5. Questions? Okay, really, on U substitution, the only thing that really can cause problems is if you choose the wrong U value. If you've made the correct choice here, the rest of the process is a memorized procedure. You just follow the steps every single time, same steps every single time, and it always works. So the next step is to take the derivative of both sides of this equation in terms of the input variable, which is y. So I say d over dy of u, and then d over dy of y squared plus 5. Questions? Perfect. This side can't really do a whole lot, so I just write du over dy. This side, somebody can earn a ticket and tell me what does that side become for him? Y. So we have a question to there. The next step is always the same. Well, let's leave this alone for a second. Let's go to the other column. We need to start making our substitutions.
Question.
Oh yeah, please.
How did that just become 2y?
So the derivative of
The bottom one, the 2y.
this one here?
Yeah.
Yeah, no worries. So the derivative of y squared plus 5, you would split this into two derivatives because it's being added. Is that your question?
Yeah.
There you go. Please.
Why isn't it 1 prime, like 2y 1 prime?
Oh, gotcha. So what I really would have done here is this. Let me just show a couple more steps, Kelsey. Oh, I hate that. I'm saying I want to circle this. Such a smart
Now
board.
you gotta pinch it. Get those, the dots on the top.
Dots on the top.
Yeah, like move it.
Yeah, like when it like expands, can you just move it down?
Oh, interesting. We'll try that. 12 years before, never thought of that. Guess who's stupid is me. Oh. Worse. Thank goodness for the ever reliable undo button. So, anyway, here's what you do. Who asked the question? I forgot. There we go. Kelsey. The middle step here is this. I get du. I get du over dy, and then I would split this into two of them. You okay with that, Kelsey?
Yeah.
And then what's the derivative of 5 in terms of y, Kelsey? So that one we don't worry about, right? Okay, this derivative here, what's going to happen is you've got du over dy. The rule says bring down the 2, multiply by the y, subtract 1, and then you have a dy over dy. Do you see that? But what's dy over dy equal to? What you're mixing it up? 1. Yeah, you're mixing it up with some other problems that would have looked like this. The derivative of y squared in terms of x, which is not what we have, but you will still encounter this in different situations. So this becomes 2y, subtract 1, and then it would be dy over dx, which can be abbreviated as y prime. That's what you're remembering. Does that make sense? Good. So you know that. There we go. So erase that little extra thing. Okay, we need to go to the other column now. So I start making my substitutions. So I write the antiderivative of, let's see, the y is still there. But I have 1 over u now. dy. Questions are there? Do a quick rearrangement. Questions are there?
So you just split it into two.
Right, because U substitution is easier to understand if I think of it as two functions being multiplied.
So you don't only just think about it, but you write it.
It makes it easier for me. You don't have to, but just a little easier to explain, so. Awesome. Okay, I made one substitution, I need to make another. I need to replace this right here, the y dy. So, over here is how I figure that out. I multiply by dy. You always multiply by dy. That's standard step, you can just memorize it. Move the 2. Now I know what y dy is the same as, that's what equal means. So anywhere I have written y dy, I can write 1/2 du. They mean the same thing. Pause for question, please.
So, I'm really confused, because don't you have to multiply both sides by the same thing in order for it to still be equal?
Keep talking, Chet, you're doing great.
So like, and the du to y dy, when you multiply the dy, just put it on the to y side, when you have to multiply the du by dy as well?
What I did, your question is very good, 2 tickets for that. What happened here, we'll try this one more time. Why does it do that? Oh, well. What happened right here is we literally multiplied this side by dy. So if I put a dy right here, how does, you see it?
Yeah, I see it now.
So I put a dy there and I put a dy here. These divide out.
Okay, I just didn't see that.
You're good. No, it's totally legal. It's a great question. Please, sir.
How does that go away?
Say it one more time.
This might be kind of stupid, I don't know if I'm
What's that?
missing it, but, the du equals 2y dy, and then you go down to the next line, where does the 2 go from on the right side?
Oh, what we did on the next line is we said, let's multiply both sides by 1/2. So multiply this side by 1/2, which means, as Chan said, I have to multiply this side by 1/2.
Why'd you multiply by?
I'm just trying to figure out this thing right here.
Oh.
So I want to find something to put in place of y dy. That makes sense?
Mhm.
Sarah, you good? Take it. Please, David.
What's the difference between du over dy and just du?
Du over dy literally means the small change in u, infinitesimal change, divided by the infinitesimal change in y. It's just a division. Altogether, we think of it as being a derivative, because derivative means change in output divided by change in input. But separately, it's just a change. And in the antiderivative process, you don't even have to think of that. It's really just kind of a symbol to indicate that we're supposed to take the antiderivative. We're just manipulating those symbols to kind of get us to a point where we can use a formula. Take it, please.
So does u equal y squared plus 5 or 2y?
U is equal to y squared plus 5. We figured out that 1/2 du is equal to y dy, but take it for that. Cool. So we come back over to the green side, do another substitution. Oh, we've done the substitution. Pull out the 1/2. So pull the 1/2 out. Okay. The overall purpose of a U substitution is to start with an antiderivative expression for which there is no formula, and then do 2 substitutions, get an antiderivative expression for which there is a formula. We've done it. What's the formula for 1 over u? Kelsey? So the antiderivative of that becomes what, Kelsey?
The absolute value of u plus c.
Nicely done. Take it up. Please remember that the plus c is just a reminder that this is the derivative of something. Whatever we took the derivative of, there could have been a plus number at the end, because when we would have taken the derivative of that plus number, it would have become 0, and you wouldn't notice it anymore. So you don't have to write plus c all along if you don't want to. You can just put it on the very last step. So my last step is to substitute back the value of u. y squared plus 5. If I take the derivative of what's in the green box, I will end up with what's in the red circle. That's what antiderivative means. Chance, please.
So when you, on the third to bottom step with that, so originally it was dy, but now the operator has just changed to du because the y has been like replaced in essence by that u. So that's the correct thing to do.
That's perfect. Take it for that. Awesome. Let's do another one. Write that one down, please. So same thoughts again. Same thoughts. We have to have two functions multiplied. So someone just raise your hand, earn the ticket. Ellie.
X squared and e to the x are.
For that. I have a question to there. Next line. Let's see. We think of the 5 different forms. And we identify what forms we have in this case. Somebody else? Sora, please.
Something to the number and then e to the something.
Nicely done. So this is definitely something to a number. And the other one is e to the something for Soren. So that means my choice of u, I have two choices then. Somebody tell me what are the two possible choices for u. Let's go, Lexi.
X and X.
Okay, give me 1 or 2. If the choice, if everything here makes sense, if you show me 1, it doesn't show me 2. Go. 1 or 2, if everything here makes sense. We have two functions being multiplied. First function is of the form something to a number. Second function is of the form e to the something. Therefore, our choices of u are the x, because it was something to a number, that's the x. And then the e to the something was x cubed plus 1. Take it for the room, David. Do you have a question?
No.
Just make sure you went like this instead of this.
Oh.
Please.
How come the first u wouldn't equal x squared and not just x?
Gotcha. So the thing you look at, Lindsay, is this function fits this pattern. Do you agree?
Mm-hmm.
Okay.
Oh, I see.
You see it?
Yeah.
Yeah. And there's not always parentheses. The parentheses are just my little symbol to kind of help you see this.
Okay, thank you.
Take it for Lindsay. Anybody else? Awesome. We've already talked about you can't pick this. So now let's just draw the line and go to work. So I think you can do it. Go. I'll just walk around and get stuck. Just stop me. I'm just gonna know you're good at multiple. That's fine.
sites do you? Yes, like you're just taking the trigger from them, so that would be X cubed. And the next line, you always take the derivative in terms of the input variable, so in this case it would be d over dx. And then this side, just d over dx. But here, d over dx, we can operate on this. So we think of them separately, they're added. What's the derivative of 1? What's the derivative of x cubed? Just the dx. So once we get to here, we're always going to get rid of constant just to make life easier. So we multiply both sides by a third. You can do that in heck. What would be the result if you're trying both sides by a third? 1/3. Perfect. That makes sense now. So now we're back over this column. We want to start making substitutions. So we're working on this antiderivative. What's the first substitution? Where is it? Here, we told us that n is equal to x squared plus 4. Using the x squared. So instead of writing b to the x cubed plus 1, we can write x squared. It's all about equality. The reason we're allowed to write this is because we have told the grader that u and x cubed plus 1 are the same thing. So he says that's legal. But you haven't done anything to replace this. The next line, we remember the big picture is we're trying to transform this antiderivative expression from an expression that has an x squared and then into an expression that has way past the u. You gotta get rid of the x squared and the x squared. So I reorder it to make it easier to see. Expressing the u, x squared. Because it's just it's like, is it being raised to 2? So the derivative of 2x
Hey, look up. Hey, look up. Yeah, I want to get it on the board just so make sure no one has any questions. So I'll pay tickets for each comment that you make. I just need someone to raise their hand and tell me what to write. Sorry.
Let u equal x cubed plus 1.
Nice. Heidi, please.
And then do d over dy of u,
dx in this case.
okay, dx of u equals d over dx, the derivative of x cubed plus 1.
No, it's per, d over dx is fine. You said it just perfectly.
Okay.
Take it for Heidi. Go on. Go, Bailey.
And then on the other side, I did, to start with, I did the antiderivative of x squared e to the u dx.
And again, ask, like, the questions today have been just superb. So any question comes to mind, just raise your hand. Start, go ahead.
Well, then go ahead and write, you reorder it so it's antiderivative of e to the u x squared dx.
Perfect. Take it. So Elliot.
Blue side is u over dx equals 3x per second.
Take it.
There. Question, why do you need to switch it? To
Oh.
e of x squared.
It's not required, but if you remember the overall goal of the problem, it helps. So I'm starting with an antiderivative that uses x's. I'm trying to get down here to an antiderivative that uses u. And so what I noticed on this line is that I still have to do something to get rid of the x squared. I'm good with the e to the u, but I've got to get rid of the dx as well. So I just reordered it to put the things I need to substitute for together.
Okay.
It just makes it easier. And you can memorize that step. That step always helps. So take it for that. Somebody else? Lexi, please.
So then you have it by dx on both sides.
Over here, so come back here, I say that's going to be du equals 3x squared dx. Go, Landon.
Divide the 3.
Take it for Landon. Let's go, Sydney.
Then on the green side, antiderivative, we have u, and then substitute the 1/3 d over x squared dx.
Take it for Sydney. Great.
Take the constant out of the 1/3, so it's 1/3 antiderivative of u dx.
Take it for Brady. It's perfect. Heidi, please.
And then you use one of the rules, and you get 1/3 e to the u plus c.
Nicely done. And I'm going to save the C, take it for Heidi, just because I just remember that, yeah, eventually there's got to be a number there, but I don't really want to write it 6 times or whatever, so. Please, Brady.
And then you put the u back in, or the whatever u was, so it's 1/3 e to the x cubed plus 1.
Take it for Brady. And if I take the derivative of what's in the green box, I will find the expression that I've now circled in orange. Question? Outstanding. Okay, we need to look up now, new, just a slightly, actually new trick. You need to understand this trick to answer a question that's going to pop up here in a second. So I want to show how the trick works on the 2 problems that we've done so far. So, actually the 3 problems, because we did this one last time. Here's the trick. We identify, let's go here where it's written out a little better. We identify that u was going to be x cubed plus 1, okay? Once we identify this to be the choice of u, if we look back at the original problem, a very interesting thing will happen. Our choice of u is here. Okay, if we take the derivative of our u, you just say it out loud. What's the derivative of this? Say it. 3x squared. Okay, just mentally ignore the 3. You have an x squared, right? That's supposed to be the other function.
Whoa.
If U substitution is going to work, that will always happen. Okay? One more time, ready? One more time. It'll always happen. It's a good trick to know. It really helps. For example, once you know the trick, you can do this really fast. Like I can take, not every problem, because sometimes they get a little bit complicated, but I can take nearly every problem on the AP test. At a glance, I can tell you what U's supposed to be. And, no, seriously, look, and you can do the same. If this trick makes sense to you, you'll be able to do the exact same thing. So we chose U to be x cubed plus 1, correct? Okay, that means we're going to, the U is a part of this function. I still have to think of two things being multiplied. But now what I do for the trick is I just take the derivative of the U in my head. What's the derivative? Say it again. 3x squared. Just ignore the 3, so you have x squared. That's this, every time. Let's go back to the last one. Okay, say it out loud. What did we choose U to be in this problem? Louder, yeah, louder. Y squared plus 5. So look, hey, you still have to think, can't talk. You have to think of two things being multiplied. There's the y multiplied by the 1 over y squared plus 5. Because our choice of U came from here, what we're going to do is take the derivative of U. Please say it out loud. What's the derivative of this? 2y. Ignore the y, ignore the 2. Did we get the other multiplying function? Yes. Every single time. Let's do another one. Look here. What did we choose U to be? Say it. T squared. So the U is a part of the cosine of t squared. What's the derivative of t squared? 2t. Ignore the 2. There's the other multiplying function. Great.
What's the point of this trick?
The trick. No, it's a great question.
I asked the same thing just for everyone.
It's all good. Hey, oh, shh. Oh, maybe I misunderstood the question. Sorry. Are you saying what's the point of U substitution, or what's the point of the trick?
The trick.
Gotcha. Watch this. See if this answers your question. So here's the worksheet you're doing for homework tonight. And the assignment is basically just to finish, like do the ones that you haven't done yet. So as I look down this list, right here is a problem that's going to require U substitution. So watch. Here's the point of the trick, Landon and Braden and everybody else. The negative 24 is a multiplying constant, so I'm going to pull that out anyway. I look here and say I've got two functions being multiplied, x squared and e to the 2x cubed plus 1. I immediately notice something interesting. This is a little bit small. What is the derivative of 2x cubed plus 1? 6x squared. Ignore the 6. Did you get the other multiplying function? I know that's the right choice.
The right choice
For you.
So it's like a
The choice, yeah, the two things have to work together.
Okay.
So my choice of U has to come from one of the multiplying functions, but that choice, the derivative of that choice, has to be the other multiplying function, ignoring the constant. Haley, please.
So does it like consolidating the system, we should be choosing the right U?
Yes. Hey. That's the point. Is to do a quick check to see if I'm choosing the right U. Look here again, look here. Hey, watch. I could have chosen, actually, let's do an example. Let's do more questions. Chance has a question. Go.
Why does that work?
It's because of this. Look here. As we were doing the process of U substitution, notice that the first replacement is just a direct replacement. So I know that this function is not going to be a concern because I've already transformed it to use the letter U. But I've got to somehow get rid of that thing. Well, how do I get rid of it? Always the same way. I take the derivative of this, do a bunch of steps, and there it is. That's why the trick works. That makes sense? Yeah, that does. Take it. Haley.
So in both the problems we've done, like the opposite of the one that we can't do and one like so it's obvious things. Will there be ones where they're both like possible, so you have to check it and that's how you decide which one, because only one will work?
Glad you asked. Perfect. Yeah, that's why I brought it up. Perfect question. Take it, Derek.
And so I get why it all works and stuff, but I don't get how doing a derivative helps us undo the derivative in the end. That just seems kind of.
It does seem kind of counterintuitive. I
Yeah.
get that. It's all about just making the appropriate substitution. That's all. It's just about making. No, it's not really part of doing the antiderivative.
Okay.
It's just how we get the substitutions to occur. So Haley's question is, where is the trick useful? Here's a place where it's extremely useful, and I'll show you why. So write this down. Write this down. Come on. So we think over here, U substitution. And we say we got to have two functions multiplied. Two functions multiplied. So someone, hey, what are the two functions being multiplied? Hand, please. Haley.
4 equal to the x and 4x.
And I'm actually going to take the 4 out of the antiderivative, so I don't really have to worry about it, so I won't include that. Is that okay? Take it for Bailey. So this is going to become, draw my line. So my first thing was to actually just pull out the 4. Questions to there? So we've got our two functions being multiplied. So we think of the 5 different forms. Something to a number, e to the something, 1 over the something. The forms are all the same pattern as the rules themselves. So now I need to identify which two forms I have. Somebody help with that, please. Ready?
E to the something.
So if I have e to the something, what's my first choice of a something? 4x. Take it for Braden and the boys who spoke up with Braden. Oh, Sydney, sorry. Good. What's the other form, Anne, please? Go, there.
Is the e to the 4x minus 2.
And therefore, the u
U
choice would be
e to the 4x minus 2, right?
nice. Okay, give me 1 or 2 fingers if all this makes sense. 1 or 2, please. 1 or 2 if it all makes sense. 1 or 2 if it all makes sense so far. Take it from the room. So now it's Haley's question. Look, this was yours, right, Haley? Notice how both choices are valid from the standpoint of we don't have that simple, u equal x case anymore. So now the trick is helpful. We'll stay on this until everyone shows me that it makes sense. I'm going to make the wrong choice first. It will help you see it better. So I'm going to say I want u to be this. That means that back here on the two multiplying functions, here they are, this is going to become e to the u. And then as I said to Chance, we're going to do a bunch of derivative. We're going to do a derivative here. The derivative of u should end up being the other function, the other multiplying function. So just say it out loud. If the choice of u is 4x, what is the derivative of 4x? 4. Is the other multiplying function 4? No. That's a bad choice.
So,
Talk to me, Anna.
will it not work if you do it that way?
It won't. So give me a 1 or 2 if that little trick not working makes sense to you. Like that's a bad choice for you. Take it for the room. Let's make the correct choice for you. So if this is my choice of u, Chen saw it very nicely. That means this right here is going to become u to the 5th. So I won't have to worry about that anymore. But I'm still going to have to take the derivative of u and replace this. So say it out loud. I'll help you. The derivative of 2 is 0. Okay, the derivative of e to the something is going to become e to that something times the derivative of the something, which would be 4. So we have 4e to the 4x. Don't worry about the 4. is e to the 4x the other multiplying function? Yeah, that worked. Okay, give me 1 or 2 if that feels good to you. If it doesn't, give me 2, it's fine. So that's where the trick is actually very useful, so that you know you're getting started properly. Okay, good. So, do that one, go. Once you have the right choice of u, the rest of the steps are memorized. It's just knowing the procedure now. So, do the steps. I'll walk around if you need help. Go. It's always the same. Oh yes, it's always the same thing, that dividing by 6 is no different than multiplying by 1/6. So either way, it's they don't. It doesn't matter. In a multiple choice answer, they'll probably, well, they actually kind of go back and forth and say it both ways. Ah. Yeah, great.
Did you get it right?
Well, that's. We're like well, that's what. That's that.
We need help?
They don't spawn. It was so big. They also tried to way
But I got
it does get it does get seems like the 35% barrier.